Leslie DeChurch, and I am the moderator of the scientific session, Understanding and Enabling Human Travel to the Moon and Mars. Thank you for joining us. This presentation is one of 3 pre-recorded videos focusing on a speaker's material before all of the panelists come together in February during our live discussion. In this video, I'll be presenting on behalf of Dorothy Carter and sharing her team's most recent findings from Project Fusion, a series of qualitative and quantitative studies designed to identify optimal countermeasures to support the functioning and performance of spaceflight multi-team systems.
Hi everyone, my name is Dr. Dorothy Carter. I'm an assistant professor of psychology at the University of Georgia. My research focuses on how leadership and teamwork allow organizations to achieve big goals. My talk today will be focused on how we can support the multi-team systems that will be taking us to the moon and Mars. So we already know that missions to the moon and Mars will be requiring unprecedented levels of teamwork. NASA has revealed the Artemis moon mission team shown here. We know that members of this group will need to collaborate and maintain a positive psychological environment in a dangerous and cramped situation for a long period of time. When NASA has a big goal, like sending a team on a long duration mission, the experts are forced to work backward by identifying potential risks that could prevent mission accomplishment, and then by determining how best to prevent those risks. As you may have heard in other talks in this session, one critical risk NASA has identified is what's called the team risk. And this is the risk of performance and behavioral health decrements due to inadequate cooperation, coordination, communication, and psychosocial adaptation within a team. The identification of this team risk has led to quite a bit of research on how to support collaboration among members of the spaceflight crew itself. But I'd like to point out that missions to the moon and Mars are certainly not the sole responsibility of the spaceflight crew working in isolation. These missions will only be achieved through collaboration across big, complex systems composed of many teams working together. In fact, long duration and long distance missions present what we call superordinate goals. Those are big picture goals that require coordinated efforts across multiple teams that need to work together as they each handle separate aspects of a larger problem. For example, long duration missions will likely require that the spaceflight crew collaborates directly with NASA's Mission Control Center, as well as the ground control for our international partners. In turn, the front room teams and mission control will need to coordinate and collaborate with a variety of backroom teams that specialize in different areas of expertise relevant to the mission. So these complex systems of teams that pursue joint superordinate goals are known as multi-team systems in the organizational sciences. Multi-team systems are defined formally as organizational forms composed of 2 or more teams that interface directly and interdependently toward the accomplishment of collective goals. And there's many benefits to organizing work into multi-team system structures, which is why NASA has long relied on these structures to support previous spaceflight missions. For example, multi-team system structures offer greater flexibility than traditional bureaucratic organizational structures, but simultaneously greater resource capacity than any single team. These structures also support team specialization, which allows systems to divide and conquer big picture goals. However, research also shows that working within a multi-team system environment can present some serious challenges. In order for these systems to achieve big picture goals, the people in them need to collaborate across team boundaries with members of other teams who often have different norms, priorities, areas of expertise, frames of reference, and that sort of thing. Unfortunately, as humans, we often struggle to collaborate with those who see the world differently from ourselves. So we can really revise the so-called team risk to clarify that mission performance could hinge on addressing the risk of performance and behavioral health decrements due to inadequate cooperation, coordination, communication, and psychosocial adaptation, both within as well as across the teams making up multi-team systems. And so I'm leading a project called Project Fusion that is focused on mitigating this multi-team risk. This project involves basic research. We're leveraging archival documents, interviews, and observations with subject matter experts, and data collected through controlled laboratory and analog experiments to understand the key drivers of multi-team system effectiveness in spaceflight contexts. But we're also engaging in a series of applied research studies where we're identifying countermeasures or interventions that can be used to directly support system performance in future missions. And our work certainly indicates that NASA's spaceflight multi-team systems have adapted really successfully to the challenges of previous eras. For example, the multi-team systems in previous eras have enhanced their technical expertise and training and refined their multi-team communication and reporting structures, both within the organization as well as across the organization with international partners. But we also know that future missions are going to require that these systems adapt even further to meet new demands. Luckily, the science of teams and work behavior can do a lot to advance the type of countermeasures we use to help ensure that collaboration is effective both within as well as across teams in future missions. Here I present some examples of the types of countermeasures that our team is advancing to be used across the lifespan of a mission, meaning during planning stages, preparation, and throughout ongoing mission performance. So to begin, in planning for major missions, NASA leadership need tools to understand and guide the design of the multi-team system. One countermeasure that can be used in the planning phases is called a multi-team system task analysis. So a multi-team task analysis is just a structured way of systematically understanding the key characteristics of the multi-team systems that will be involved in the upcoming mission. And the first step of this process is to determine what main goals and objectives will be involved. But we have to account for how complex these goals can be in a multi-team system environment. Therefore, we have to ask not only what the goals of each separate team are, but also how these goals align with or conflict with the overarching goal that is shared by the entire system of teams. We also need to map out which teams need to interact directly with one another so we can best support critical inter-team interactions. In the preparation stage, tools are needed to support team members' understanding of and preparedness for working in a multi-team system environment. We can't expect that everyone recruited into the mission for their areas of expertise also knows how to best work in a complex system of people. Indeed, differences in expertise are often accompanied by differences in how we communicate information, our past experiences, and our expectations of others. Therefore, in addition to any technical training, we need to train people on how to collaborate most effectively in multi-team system contexts. So as part of Project Fusion, our team is developing a training simulation that's designed to instill critical knowledge and skills about inter-team collaboration strategies that are known to enhance system performance. Our initial validation studies suggest that participants' knowledge of multi-team system challenges and collaboration strategies was significantly greater after completing our multi-team training simulation in comparison to a comparable team training simulation. Finally, in the ongoing performance of a mission, it will be critical to success that team members continually learn and find ways to adapt to the challenges they face in pursuit of mission goals. Therefore, system members need a structured and consistent way to learn from their mistakes and successes and to develop and enact ways to change their behavior to improve performance. Team debriefs offer such a structured system of learning and adaptation. So team debriefs are a guided process of having a team reflect on past performance phases, what went right and what went wrong. In Project Fusion, we are leveraging our interviews with subject matter experts to expand team debriefs to include crucial between-team considerations. Including multi-team or between-team considerations gives individual teams a clearer and more comprehensive understanding of the goal of the system and how their own team's goals and contributions fit into the larger system puzzle. So it's my hope with this brief presentation that I've highlighted and reinforced the importance of considering the complex dynamics involved in the types of multi-team systems needed to achieve big picture goals like interstellar travel. Further, I hope that I've gotten across that these considerations must happen at all stages of the mission, from planning to preparation and training to performance. So future long-duration missions will require great investment on behalf of NASA leadership and those working in this mission, as well as input from former NASA's experts and external experts. But I'm sure this investment will pay off in terms of the effectiveness and safety of space missions by accounting for the potential pitfalls and best practices in complex teamwork. Thank you for your time. My email address is on the screen.
Just a reminder, this is but one of 3 spotlight videos focusing on the individual work of the speakers before they all come together for our live panel in February, Understanding and Enabling Human Travel to the Moon and Mars. Please check the AAAS annual meeting website for the panel's date and time. Again, thank you, Dorothy, and to you, the audience, and we will see you live in February.